All right, welcome to the kind of rare late night video. It's Friday night, so what better time than to read a book on machine learning for cloud and network engineers. So, this next section is on decision trees. Decision trees algorithm and its derivatives are some of the most essential techniques due to various factors: their ability to capture nonlinearities, the speed of training, and the good level of explainability. We will review this later in more detail. They are very intuitive because somehow they mimic the way we humans make decisions. We introduced some of the concepts behind them earlier when we discussed isolation forest in the anomaly detection section, and unfortunately, I don't remember any of that. So you know what? Let me do this. This is kind of cool. A cool usage of ChatGPT. So I got to get this to close. So I'll hit the escape key, and then what I'll do is I'll take a screenshot, and I'll make sure I can get the name of the book in there, all of that. And then I'll paste the screenshot into ChatGPT, and I'll say, I forgot about forest isolation, I think it was. I don't even remember what it was. Yeah. Isolation forests. About isolation forests. Forests. Please bring me up to speed. All right, and I have to fix the sound. All right, and I might have to regenerate if it doesn't. Oh, you know what? It looks like my tool got uninstalled here, so we're gonna wait for that to complete. It's completed. Hit refresh, and it looks like my tool is still not installed. So, um, uh, so let's go to settings, and then speech. Uh, so interesting. So how can I enable? Okay, so I have to use a browser extension. I had one, but that I was really happy with, but it deleted itself. So okay, so my it looks like my extension is still okay. So it looks like the extension for some reason is not working. Yeah, usually the extension is added there. It's now completely different. So I need to revert it to get back to where it was. Okay, so there's some sort of issue where the extension does not work anymore. I'll try closing the browser and reopening it. Okay, so there's still an issue where the extension does not work. Okay, so I'm going to completely remove it from Chrome. All right, and then I'll reload this page. So make sure it's still gone. It's still gone. And now I'm going to add it to Chrome. All right, so now it's been added to Chrome, but it's still not a part of Chrome. All right, so that's interesting. Not sure what's going on with that. So clearly, I need a different sort of extension. Now, ChatGPT did recommend one, so let's go back and look at the one it recommended. Okay, so now we have an extension here that will read text out loud. But what I really need is an extension that will take in input from my microphone. So one of the things I might be able to do is change the site settings to allow input. Uh, so we will definitely allow sound from it. And then we'll keep that the way it is. Okay, so the microphone will allow the microphone. All right, and let's see if that makes a difference. Okay, so it took a while to load because there's new settings, presumably. And okay, so now it's still not working. Also, I'll try closing it and reopening it again. Okay, so it's now completely gone. So that's too bad. I guess I'll go back to the extension. So I'll go here, click the extension, and we can see the extension is presumably working. But let's get the name of the extension. So it's voice control for ChatGPT. I'll just put that into good old-fashioned Google and see why that isn't working. So let's put in not working. Okay, and my input is working. We can see it's through my line complete one. My output is working as well. So and we can see it is in Chrome. Otherwise, we wouldn't have the option to remove it. And then we can see if I click on it here, it actually tells me to go to ChatGPT. So I go to this special link, and it's still not there. So yeah, there's some kind of issue, unfortunately, where I can't use this extension. And if I can't use this extension, I really... Oh, here it is. So see here? So the latest ChatGPT update wreaks havoc on voice control. An extension update is being reviewed. Please use the manual extension. So let's do that. So the first thing we need to do is click this to download the file into my downloads. Then we're gonna find that file and unzip it. So extract all. All right, and then we're gonna go to Chrome / extensions. All right, and then developer mode, which is checked to on, so that part's done. So then the next part is load unpacked. There we go. And then we'll click the folder there, select folder. Okay, and then that's it. It should now be available. Okay, so it's not seeing a manifest file, so I think I selected the wrong folder. So let's go back to the downloads. And now we've got voice control later. Okay, so now we've got dist, we've got assets. So let's go. Let's select this dist folder now. Okay, and that was the correct folder to select, the dist folder rather than the top level one. So that'll probably trip up a lot of people who aren't as skilled at this sort of thing. So be aware of that. So now we've got the option to set Maya AI as default startup page. Let's check that. Well, sorry, we'll deny it for now because we have the option to go back later. But yeah, so that looks good. So the next thing we need to do is toggle it. We need to change the settings. So here's how we change the language. But now we can do the talk to AI. We can click here to start.
Whoa, who just popped into my digital world? Say your name, you mysterious being.
Oh, that's interesting. So I can get it
Hi, click here to start. I'm Mia, nice to meet you.
Oh, okay. Okay, so I'm just wondering if this is working.
No way. Oh, okay? Just teasing. But seriously, where's home for you? How is it living there?
Okay. Well, this isn't working the way I thought it would. Well, you know what? It's better than nothing. Let's go back here and let's regenerate this, and hopefully it will say it out loud. I don't know where the settings are, but hopefully those will reveal themselves. There might be a way to revert to a prior version of ChatGPT as well, which would be really nice. I think this speech setting tab here is for the app, the mobile app. So if I toggle that, it'll just toggle what I get with the app, but it won't actually read things back to me. So looks like I have to do it differently. I have to do it in a different tab. So let's take the screenshot here and then go and put this in now that the extension is installed. Oh, and it looks like the extension, okay, it is installed, so good. All right, so we've got a bit of a problem here. It's not, the extension isn't working. It's not reading it out. So I guess I would have to move. Let me do
Isolation forests are a type of algorithm primarily used for anomaly detection. They work by isolating anomalies instead of profiling normal data points. Here's a brief overview of how they function. 1. Random partitioning. Isolation forests randomly partition the data by selecting a feature and then randomly selecting a split value between the maximum and minimum values of the selected feature. This process is repeated recursively until the data is isolated into individual points. 2. Tree structure. The partitions create a tree structure. In this tree, normal instances are isolated later, having longer paths in the tree deep in the structure, while anomalies are isolated earlier, with shorter paths closer to the root. 3. Anomaly score. The path length to isolate a sample is used to calculate an anomaly score. A shorter path results in a higher score, which indicates a higher likelihood of being an anomaly. Efficiency and scalability. This method is both efficient and scalable, making it well suited for high-dimensional datasets where traditional distance-based methods may falter due to the curse of dimensionality. Isolation forests are advantageous because they require fewer resources, are faster, and often yield better performance in identifying outliers in comparison to many other methods. They are particularly effective with large datasets and datasets with a complex distribution of normal instances.
All right, so I left them pretty negative feedback here because there's no yay. Okay, never mind. So I figured it out. So you just uncheck that, and now you can get a faster voice, or you can choose any of the voices here. So let's maybe try selecting some of the other voices. All right, and I don't hear anything, so I don't think I will hear anything.
Isolation forest is an algorithm used for detecting anomalies or outliers in data. It's particularly effective for high-dimensional datasets. Here's how it works. 1. Random sampling. The algorithm randomly selects a feature and then randomly selects a split value between the maximum and minimum values of the selected feature.
All right, so it
2.
sounds
Partitioning. Using the split value, the data is
so it sounds a lot more like real language, but I don't want it to sound like real language. I want it to be faster than that. I want it to, yeah. Oh, look, I can set the different ones. So I forget what I was using before, but yeah, so testing.
Hello, how can I assist you today?
Oh, there we go. And then there's other ones like Zeek. There. Now I can use this in a natural way, the way I was using it before. So, give me some Shakespeare. Read me some Shakespeare. All right, so it's a lot slower than before. You know what? I'm pretty happy with that other voice, so we're just gonna keep it at that voice. Looks like we can add some more voices, but I'm pretty happy with how it
Certainly.
was.
Here's a passage from one of William Shakespeare's most famous plays, Hamlet, from Act 3,
Yeah,
Scene 1,
I
where
like
Hamlet delivers
this.
the iconic to be or not to be soliloquy. This soliloquy delves deep into Hamlet's contemplation of life and death, embodying his existential struggle. It's one of Shakespeare's most profound and philosophically rich passages.
Yeah, I like this. So, okay, so I'm happy with that now. So now we can move on. So give me a primer to bring me up to speed quick on the concept of isolation forests when it comes to the context of machine learning anomaly detection. There, see how easy that is?
An isolation forest is a type of machine learning algorithm specifically designed for anomaly detection. It operates on the principle that anomalies are data points that are few and different, and hence, they're easier to isolate from the rest of the data compared to normal points. Here's a quick primer on the key concepts and how isolation forests work. 1. Conceptual foundation isolation. The core idea is to isolate anomalies instead of profiling normal data points. The algorithm attempts to isolate each data point by randomly selecting a feature and then randomly selecting a split value between the maximum and minimum values of a selected feature. Path length. The number of splits required to isolate a sample is recorded. Anomalies, being few and different, typically require fewer splits to be isolated, which results in a shorter path in the tree structure. 2. Algorithm structure tree construction. The isolation forest consists of many decision trees, which together form a forest. Each tree is grown by randomly subsampling the data points and then recursively splitting the data. This split depends on randomly selected features and split values. Termination. The recursive partitioning can continue until every data point is isolated, but typically it stops when the tree reaches a certain height, limiting the maximum path length. 3. Anomaly score calculation. Once the isolation trees are constructed, the path length for a data point can be used to calculate an anomaly score. A shorter path length results in a higher anomaly score, suggesting a higher likelihood of being an anomaly. Normalization. The path lengths are normalized by the average path length expected in a tree of the same size. This helps in comparing the anomaly scores across different datasets or subsamples. 4. Advantages scalability. The algorithm is highly scalable with respect to the number of samples, making it suitable for large datasets. Efficiency. It has low computational cost because it builds trees using a small subset of features and does not require distance or density calculations. Non-parametric. It does not assume a normal distribution of the data, which is advantageous in real-world scenarios where data often deviates from theoretical distributions. 5. Use cases fraud detection, identifying unusual patterns that do not conform to expected behavior, such as unusual credit card transactions. Network security. Detecting anomalies in network traffic that could indicate a security breach or cyber attack. Industrial damage detection. Spotting faults or failures in mechanical systems by identifying data points that deviate from normal operational metrics. 6. Limitations randomness. The randomness in tree construction might lead to variability in the results. Ensemble methods can mitigate this by averaging over many trees. Data imbalance. Highly imbalanced data can bias the isolation towards the majority class, potentially ignoring subtle anomalies. This primer should give you a basic understanding of how isolation forests work in the context of anomaly detection within machine learning.
Apologize for that. I don't do this often. I'm hoping not to make it a habit, but yes, I was in the kitchen chopping up some mushrooms that I will make into mushroom jerky. So I can hear everything when I'm away from my computer. I just can't speak into the microphone. But I was listening. You know, the goal is to just get a quick refresher and get up to speed, and then to move on with reading the rest of the book. While we are in the regression section, decision trees, like other techniques, can be used for regression and classification. I will explain the technology and the fundamentals of the algorithm here. The fundamental building block of a decision tree algorithm is the iterative division of the dataset into smaller groups. This division is based on one of the independent variables. Progressively, the groups are smaller and smaller until they can be associated with a unique label. They become leaves on the tree. In the tree node, the algorithm will split the space associated with that node by one of the variable features into two subspaces. If we think of a 2D representation where we visualize those two features, each node in the tree represents a subdivision of each rectangle into two smaller rectangles, similarly as we saw in isolation forest. There we go. Let's see what ChatGPT has to say about this. It's so easy to prompt it now that I got this extension working again.
It looks like you've uploaded an image of a scatter plot. What would you like to know or discuss about this image?
So just help me understand this image.
The image you've uploaded appears to be a scatter plot, which is a type of data visualization used to show the relationship between two quantitative variables. Here's a breakdown of what we can infer from a plot. Axes. The horizontal axis, x-axis, is labeled as number of ports used. This likely represents the count of different network ports that are being utilized in each instance plotted. The vertical axis, y-axis, is labeled as number of VLANs used. VLANs, virtual local area networks, are used to create logically segmented networks within a physical network. The count on this axis represents how many VLANs are being utilized. Data points. The plot shows data points in form of diamonds. Each diamond represents an observation or record indicating the usage of a certain number of ports and VLANs. Distribution and grouping. The data points are grouped in clusters, which could suggest patterns or types of behaviors in network usage. For example, one cluster might represent a standard setup in an organization, while another might indicate a more complex setup involving more VLANs and ports. The plot is divided by dotted lines both horizontally and vertically, which might indicate different categories or thresholds in the number of ports and VLANs used. Outliers. There are a few points that stand alone, not fitting into the main clusters. These could be outliers or unusual observations, which might indicate a typical network setup for potential areas for further investigation. This type of plot is often used in network management to visualize the complexity of network configurations across different parts of an organization or during different times. It could also be useful in anomaly detection, where points that significantly deviate from the clusters might indicate potential issues or unusual activities.
Okay, so the context is anomaly detection, I believe. Yeah, so the context is anomaly, is decision trees. The context is, so the context is machine learning for cloud and network engineers. So yes, anomaly detection is going to be a part of this context. So I'm including another screenshot. The purpose of doing this is just to have you act as a mentor, as a tutor, like, you know, as a supplemental resource to help me understand this subject matter faster.
It looks like the new image you uploaded depicts a schematic of multiple decision trees, which is relevant to the concept of isolation forests, particularly used in anomaly detection within the context of cloud and network engineering. Understanding the diagram multiple decision trees. The diagram shows multiple decision trees labeled from 1 to n, indicating that this is an ensemble method. In the context of isolation forests, each tree is constructed independently based on random subsets of the data. Tree structure. Each tree starts from a root node at the top. The diamond shape represents data points, and splits into branches based on certain conditions or random thresholds. The branches continue to split, creating a tree structure that eventually terminates in leaf nodes. In the context of anomaly detection, these splits are typically based on randomly selected features and split points. Anomaly detection process. In isolation forests, these trees are used to isolate observations. The basic assumption is that anomalies are few and different, and therefore easier to isolate, requiring fewer splits to segregate from the rest of the data. The path length from the root to the leaf, where a data point ends up, is indicative of how anomalous the data point is. Shorter paths suggest the data point is an anomaly because it was easier to isolate. Application in cloud and network engineering network anomaly detection. Using this method, you can identify unusual patterns in network traffic or access logs which deviate significantly from normal behavior. This can be crucial for detecting security breaches, DDoS attacks, or network failures. Resource utilization. In cloud environments, tracking how resources are used, e.g., CPU, memory utilization, can reveal outliers in the usage patterns, which might indicate misconfigurations or malicious activities. Scalability and efficiency. Isolation forests are particularly well suited for dealing with large-scale data due to their random and recursive partitioning approach, making them efficient and scalable for real-time anomaly detection in extensive cloud networks. Mentorship advice as you delve into using isolation forests for anomaly detection in cloud and network settings. Consider the following. Experimentation. Practical application and experimentation with real network data will help you understand the nuances of tuning the algorithm, e.g., number of trees, sample size. Integration. Look into how this method integrates with existing monitoring tools or platforms. Often, anomaly detection is just one part of a larger system of health checks and monitoring. Continuous learning. Keep abreast of the latest research and improvements in the field of machine learning for network security, as this area is rapidly evolving with new techniques and tools emerging. Using these trees in an isolation forest setting can significantly enhance your ability to preemptively spot and react to anomalies, thereby maintaining system integrity and performance.
Alright, so I'm back. Next part of the book is, what are the criteria for making such divisions? For classification trees, there are usually two strategies that ultimately have a lot in common. The first strategy is the Gini impurity based. Gini impurity index is a measure of the probability of a wrong classification if that was done randomly. Somehow it captures the level of heterogeneity of the sample. If there is an equal number of observations for the same class, it will be very heterogeneous, high Gini. If there were observations for only one class, it would be very homogeneous, low Gini or Gini, I'm not even sure. As with any machine learning algorithm, the goal is to minimize some loss function. In this case, Gini serves as the function to minimize. The algorithm will go through all the variables and observations and pick the variable and splitting value for which the Gini gain is maximized. In other words, the Gini is reduced the most. Okay. Which is counterintuitive because maximization usually would imply that it's not reduced, but in this case that is what that means. Intuitively, the algorithm is progressively splitting the sample into more homogeneous and smaller groups and selecting the optimal criteria at each step for such separation. In the limit, each group is entirely homogeneous, belongs to only one class, and the classification is 100% certain. Alright, so the next strategy for a classification tree is entropy or information gain based. Entropy measures the level of information a feature carries. We already saw some definitions of information earlier in the book while discussing principal component analysis and the concept of variance as a means to capture the level of information. I don't remember that at all either. Okay, so I don't remember at all principal component analysis and the concept of variance as a means to capture the level of information. This is in the context of reading the book Machine Learning for Network and Cloud Engineers. Can you please quick bring me up to speed on this concept? Keep it brief.
Certainly, principal component analysis (PCA) is a statistical technique used in machine learning to reduce the dimensionality of large datasets, increasing interpretability while minimizing information loss. It's particularly useful in contexts like cloud and network engineering where you have large volumes of data and are looking to simplify the data without losing critical information. Here's a brief overview focusing on the concept of variance. 1. Variance in information. Variance in data represents the spread or variability of the dataset. In PCA, variance is crucial because it indicates how much information a particular feature or principal component holds. The goal is to capture the most variance, and thus most information, with the fewest number of principal components. 2. Principal components. Principal components are new variables created by PCA that are linear combinations of the original features. These components are orthogonal to each other, independent, and are ordered so that the first few retain most of the variance present in the original dataset. 3. Procedure standardization. First, standardize the dataset to have a mean of 0 and a variance of 1. This ensures that all features contribute equally. Covariance matrix. Compute the covariance matrix of the data to understand how variables in the dataset vary from the mean with respect to each other. Eigenvalues and eigenvectors. Calculate the eigenvalues and eigenvectors of the covariance matrix. Eigenvectors determine the direction of the new feature space, and eigenvalues determine their magnitude. Sort and select. The eigenvectors are sorted by their corresponding eigenvalues in ascending order. This order determines the importance of the principal components. Typically, components with higher eigenvalues capture more variance. 4. Application in cloud and network engineering feature reduction. PCA can reduce the number of features and data from sensors, logs, or network traffic, making models less complex and faster to train. Anomaly detection. By observing changes in the principal components, engineers can identify unusual patterns that deviate from normal operations. 5. Benefits efficiency. Reduces computational costs by decreasing the number of dimensions. Noise reduction. Helps in removing noise from the data, as higher variance axes are less likely to be affected by noise. Improved visualization. Simplifies the visualization of complex datasets by reducing dimensions. Understanding PCA in this context will help you manage and analyze large datasets more effectively, making it a valuable tool in the toolbox of a network or cloud engineer dealing with machine learning challenges.
Alright, I'm back. And sorry, I was cutting up mushrooms again, so I didn't scroll down here. Kind of running out of steam, but let's keep going. So entropy captures the uncertainty associated with the variable. The more certainty exists, the less information it carries. The more uncertainty or variability, the more information is contained. I will skip the formula for entropy or information gain. Intuitively, the algorithm will find the variable and value such that if the sample is divided, it will result in a lower entropy. Or said differently, it will try to maximize the uncertainty reduction, for example, information gained, by splitting the sample with that variable and value. In the limit, all observations in a leaf will belong to the same class, which means entropy is 0 and there is no uncertainty. It is possible to define different criteria for when the tree training will end based on a specific tree depth or a minimum number of observations per group, etc. When we use a decision tree for regression, for example, continuous value prediction, we will typically use the mean value of the labels for the observations in such a node of the tree as a function to minimize, instead of Gini, or entropy based. It will be based, for example, on mean squared error minimization. One challenge with decision trees is that they are very overfitting prone. If you think of a decision tree whose leaf nodes correspond to every individual sample, this one is completely overfitting. That is the reason why we set some limits to the depth. However, there is also the option to perform tree pruning post-training, therefore reducing the tree's complexity and eliminating the tree's leaves, which produce a lower gain. There are multiple algorithms for this pruning process. I won't describe them, but they will result in a smaller but more resilient and more generalizing tree. Also, another critical property of decision trees is that they can easily handle ordinal, whether continuous or discrete, and categorical variables. For other algorithms, we always need to do some data gymnastics. We will review techniques in subsequent sections to get the data in the format that can be consumed. Key takeaway: decision trees with their simple logic are a very powerful technique. Very frequently, they are more adequate and effective than other more modern and complex architectures, such as neural networks. So that's interesting because everything's a neural network. But while people are using neural networks, you should now have the ability to use a decision tree. All right, so next section is ensembles. But it's got to be a short video, which for me is over a half hour. Just not really feeling it tonight, and I got to cook those mushrooms. So that's it for this video. Thanks for watching, and see you in the next one.